This is the basic setup page and is responsible for setting up a lot of the PWM inputs and outputs. So if we have a look on the left hand side here, we have the option to set up PWM in 2, 4 and 6 inputs. Now these can be set up such that we can program these as real-time inputs with special functions on a later page, or we can set these to be offset inputs. If set to offset inputs, then it means that an input on PWM in 2 is simply added to the PWM in 1 input. Let's leave these as real-time programmable inputs. We have the gyro gain settings here as coarse setting adjustments, low, medium or high options available for the axis, pitch, roll and yaw. We can switch on and off the activity LED here. And here we have the output PWMs, and we have various mixing functions. Normally there's no mixing, meaning that a pitch signal coming in PWM in 1 will come out on PWM out 1, and its inverse will come out on PWM out 2. Now we can also enable a mixing where we mix in the pitch into the roll signal, and we can decide what sort of percentage we want to mix in, let's say 70%. This is for flying wing type aircraft where there's no tail elevator, so the elevator function has to be performed by the wing ailerons. We can also mix yaw into pitch and roll. This is for a quadrotor application. And we can also output power, so we can input power via one of the programmable strobes or PWM in 7, and then we can output it on PWM out 6. The reason we might want to do this is that we also have a curves section page here, and we can set a curve to be something other than linear. So we can input power, so that here we see the stick position, and we get an output that's non-linear. We may, for example, want a square curve. So we'll talk about this later on. For now, we'll just keep this at normal, no mixing. By the way, the gyro can be switched off here with this big button, and then the gyro functions themselves will not operate, but the module will operate only as a mix doing the mix functions. So it can be used, for example, on a flying wing application, or with an aeroplane that has maybe 2 servos for the wings. It can be used simply to drive the correct servos with no gyro function. Here we can invert the outputs. Normally, as I said, the pitch comes out on PWM out 1, but the inverse pitch comes out on PWM out 2. Similarly, the roll comes out on PWM out 3 and the inverse roll on PWM out 4, and similarly the yaw and inverse yaw. Now if you had an aircraft with 2 servos for the wing ailerons, then you would connect to PWM out 3 and 4. Now you may also wish for these to be exactly the same, in which case you will need to invert the second one, because normally, as I said, you have the normal one and the inverse one. So by inverting this, you make these both the same. We also have here a mode for aircraft heli or quadrotor. I won't talk too much about this, but we'll leave this in aircraft heli mode. Now the servos, different servos can be used. Most people are using digital servos these days, but we could also support here the older, more power-hungry and slower analog servos, and also controller. This is a speed controller for brushless motors, and also support the very fast narrow pulse system. So this is the all the setups on the basic page, and we can very quickly set all these back up to their default values by hitting the default button. We also have a very important button on this page, which is the send button. When any changes are made to any of the tabs, the functions and features on any of the tabs, then you must always send that data to the BL-3G gyro. This is performed by hitting the send button, and you see it will turn red with a message saying sending, and you must wait until this is complete. You will also see a red LED light on the gyro module itself, and that will go out at the same time as this red light goes out, which shows that everything has been sent successfully.